Hi, welcome back to the next video in the IB Math AA Higher Level playlist. Today we'll be looking at the entirety of vectors, lines, and planes. Now this video covers only the essentials of what you will need for the exam, so it's quite important to be attentive as this is probably one of the most important topics that will be assessed on the exam. So let's dive right into it. So a vector is basically an arrow. So this right here is an arrow A, so it's a vector. This right here is B, so that's also a vector. And we can add these arrows. So basically what that means is that we take the length of this, we take the length of this in a certain direction, and then we add it together. So to add two vectors, we first go along the first vector. So A plus B would mean we go along A and then we go along B, and the point from the start of A to the end of B is A plus B. So basically if we start here and we want to do B plus A, that means we go along B, we go along A, and that's B plus A. Now notice this is the same as A plus B, which means that A plus B is equal to B plus A, and the value of A plus B is just the displacement from it for if we went along A and then along B. So it's just the net displacement. It's the same as, for instance, if you were walking a path along A and then along B, you would end up in the same point as if you just walked the path of A plus B. So yeah, that's pretty much it. A vector is just an arrow pointing to a coordinate. And so here you can see the addition a bit more formally. So if we have a vector A, which is just a coordinate with points A1, A2, and A3, a vector B, which is a coordinate with points B1, B2, and B3, then A plus B is A1 plus B1, A2 plus B2, and A3 plus B3. So you just add the three components of it. If we had a two-dimensional vector that means x and y instead of x, y, and z, then it would just be A1 plus B1, A2 plus B2. That's pretty much it. The same goes with scalar multiplication. So if you're given a vector A, and this just means in a vector space, but you don't need to know that formally. So if you're just given a vector A and a scalar C, then the multiplication is C times A. So for instance, if you wanted to multiply 2 times this A1, A2, A3 here, your 2A would pretty much just be 2A1, 2A2, and 2A3. So that's very straightforward. Now let's take a look at the dot product. So the dot product is basically a way to multiply vectors, and it's again very simple. I think it's best illustrated with an example rather than by showing you the formula, just because of how simple it is. So if we're given two vectors, one which is 2, 7, and 1, and the other which is 8, 2, and 8, and we want to find their dot product, all we've got to do here is just do 2 times 8, 7 times 2, 1 times 8, and add them together. So you just multiply the top row with the top row, and add that with the middle row multiplied by the middle row, and add that with the bottom row multiplied by the bottom row for each vector. So here 2 times 8 is 16, 7 times 2 is 14, and 1 times 8 is 8, so 16 plus 14 plus 8, so 16 plus 14 is 30, and 30 plus 8 is 38, so that's our dot product. And another way we can find this is using this formula here, A dot B equals magnitude of A times magnitude of B cos theta. Now this magnitude symbol here might look a bit confusing, but magnitude just means you use Pythagoras theorem. So for instance here, magnitude of this would just be 2 square plus 7 square plus 1 square square rooted. So it's just the Pythagoras theorem that you've probably already learned in like grade 9 or so. And this cos theta right here is the angle between two vectors. That's very important. So usually an exam question might ask you to find the angle between two vectors. And so what you've got to do is first find their dot product by doing this. So if it said find the angle between 2, 7, 1 and 8, 2, 8, then you have to find the dot product first. So you know that's 38 here. And then you'd find the magnitude of this vector. So the magnitude of this is a square root of 2 square plus 7 square plus 1 square, which is the same as 4 plus 49 plus 1 square rooted, which is the same as square root 54. And the magnitude of this vector in a similar manner is just 8 squared plus 2 squared plus 8 squared, which is the same as 132, and the square root of 132 is the magnitude of this vector. So the cosine of the angle between them is just 38 divided by square root 54 times square root of 132. So the theta here is just the cos inverse of that, and at that point you just plug it into your calculator because they won't expect you to do this mentally. So yeah, that's pretty much just this. If you did know the angle, you could also find a dot b without having to do this, but that just seems like an unnecessary back route, and as much as possible you'd like to stick to this definition because it's arithmetically so easy. Now let's look at the cross product. So the cross product is the second way to multiply two vectors, and just be really careful here. You can only have a cross product. The cross product only exists if and only if the vector is in 3 dimensions or 7 dimensions. Now, I'm fairly certain you won't see a 7-dimensional vector, so you can only have a cross product for 3-dimensional vectors then. So, for instance, for these two vectors, the cross product exists, but if you say you didn't have the bottom row, you just had 2, 7, 8, 2, the cross product would not exist because that's a 2-dimensional vector. So the cross product has 2 formulas. One is here, and this is given in your data booklet in a very similar fashion. The only thing is I, j, and k are replaced in a sort of matrix form. So basically what that means is that you see this right here, and this right here stacked on top of each other. They mean the exact same thing, and you're expected to know both representations, so I just thought I'll show you the alternate representation here so that you're more familiar with it. So basically, to find the cross product, this is not something you can really memorize. You usually find it using determinants, but that's not something that's covered in the syllabus. So this is given in your data booklet, so just know that A2, for instance, would be, if this vector is A and this vector is B, A2 would be 7. And B3, for instance, would be 8 here. So yeah, just keep that in mind. One really important thing with cross products is that A cross B is not equal to B cross A. With dot products, A dot B is equal to B dot A, but with cross products, A cross B is actually equal to the negative of B cross A. So if it asks you for A cross B, make sure you multiply the things in the correct order. It'll always tell you which one is A and which one is B if they want you to be so specific. Now, much like the dot product, the cross product also has a formula with a trig identity in it. So here it was just cos. The only difference here is that A cross B is the same but with sine. And yeah, that's pretty much all you need to know for cross product. So here's a quick thing to check your understanding. Compute the cross product of A and B, where A is 1, 6, 0, and B is negative 2, 5, and 0. So just have a go at that. I won't go over the answer for it because it's just sort of like a refresher, but if you want to, just have a go so that you get some practice. Now let's just look at the application of cross product. So cross product is very important because it helps us find areas. So as you probably learned in primary school, the area of a triangle is the vertical height times the base divided by 2. And pretty much what the cross product does is it finds us the area of the triangle without needing this vertical height. So what we have here is the Pythagoras theorem applied on the cross product result. And that divided by 2 is the area of a triangle. Now, as you can see here, 2 triangles make up a parallelogram, so the area of a parallelogram is the cross product and then the magnitude of that, so you apply Pythagoras theorem onto the cross product. Here's just a quick visualization of it. So if we have B here and A here, the area of the triangle or the parallelogram is A cross B, and the magnitude of that, and the area of the triangle is just that divided by 2 because this right here is a triangle. This half right here, if you slice it like a sandwich. So now let's just look at vector lines. So this is again very simple. It's the same as y equals mx plus c, except now we're expressing things in terms of vectors. So it's almost identical. It's now instead of y we have r, and instead of c or the constant, we have r0, which just means a vector anywhere on the plane, or on the line, sorry. T, which is sort of our x variable here. So t is just any x, and then v, which is sort of our gradient vector. It's called a direction vector. So basically, if I have any point, I can plug that in for r0. So if someone tells me the point 1, 3, 1 is on the line, I can plug that in for r0 as 1, 3, 1. And then if someone tells me that it points towards, the line points towards the vector 7, 1, 2, then my direction vector will be 7, 1, 2. If I'm given 2 points on the line, just like with gradients, I can just subtract those 2 points to find v, which is the direction vector. So yeah, that's pretty much all you need to know for lines. Another important thing is the intersection of lines. So basically, at this point, you'll just have to find the intersection of the two lines. So you just equate their equations. So we have r1 equals r0a plus tva, and then r2 equals r0b plus tvb, and then you equate r1 with r2 and solve for t. And then once you solve for t, you just replug it back into the equation, and then you have the intersection of two vector lines. So now let's just move on to something a little bit trickier, which is planes. Now these are not that difficult, but it's a little bit tricky at first. So if you sort of make like a plus sort of thing with your hand, so you point your pointing finger into the screen, you keep your middle finger 90 degrees from that, and then your thumb pointing straight up, then you've pretty much made a plane with x, y, and z. So the equation of a plane is n dot r minus r0 equals 0. Now this might look a bit weird, but it's very simple. So n here is basically just the cross product of the two vectors of the plane. So if someone tells you that the plane is parallel to 1, 1, 1 and 2, 1, 3, then you just have to do 1, 1, 1 cross 2, 1, 3 using this cross product formula right here in order to find this n. R0 is just any arbitrary point on the plane, so if someone tells you the point 1, 1, 1 is on the plane, then R0 is that point. Once you have that, you take the dot product of these two to get the scalar equation of a plane, which looks like this. I know this might be a bit tricky, so I'll walk you through how to do that in the next step. So try this question yourself. Oops, I'm sorry, it says here that the last vector seems to have been cut off, but I believe that that vector is a 2. So just for r, it's 0, -1, and 2. So try this question yourself, and I'll walk you through the solution very quickly. Okay, so now assuming you've solved that question, let's look at the solution. So the direction vector pq is the same as q minus p, which is 3 minus 1, so that's 2. 1 minus minus 2, so that's 3. And 4 minus 0, which is 4. So that's what we have here, 2, 3, 4. And then PR is the same thing with, so 0 minus 1, 0 minus 1, which is -1. -1 minus minus 2, which is 1 because we add, and 2 minus 0, which is 2. So that's the two parallel vectors. Now we have to find the cross product of these two vectors to find this n right here. So if we use this formula over here to find the cross product of these two vectors, we get this right here. So 2, -8, and 5. So this is our n. Now we just need to write it in this form over here. So a is basically the top variable in our n, b is the middle variable, and c is the bottom variable. So in our cross product, 2 is the top variable, -8 is the middle, and 5 is the bottom. So now we put 2, -8, and 5. Now from the question, we're given that 1, -2, 0 lies on the plane. So we substitute in x minus 1, y plus 2, and z minus 0. just keep in mind, in this equation right here, it says x minus x0. So if x0 were negative, then it would actually be x plus x0, because negative times negative makes a plus. The same goes for y and z0. So just substituting in that point, we equate it to 0. We then expand the brackets and bring that number over here. So we get negative 18 because 8 times 2 is 16, and 2 times 1 is negative 2. So then we get negative 16 minus 2, and if we add that over here, we get 18. So this is just the vector equation of the plane. So yeah, that's pretty much everything you need to know for Math AA higher level in vectors. I hope you found this video helpful, and please let me know down in the comments below if you have any questions regarding this.